there anyone in particular you didn't know how to start at all?
Well, I didn't really do a lot of this worksheet because I didn't really know what I was doing, so easier than this.
Okay. Man, it's not the right button.
Did you do this whole worksheet?
Okay. So for 1 through 4,
Because we did number 1 together yesterday, and I was trying to think about the same way we did it, but
so for number 2, little slanty. Alright, as you're coming, we're trying to find, okay, they tell you it's not differentiable at P. So we can't differentiate it there. But they want to know why by comparing the right hand and the left-handed derivatives. So the derivative, remember, is the slope. So if I'm coming from the left, what is going to be the slope at P? What's the slope of this line?
Zero?
What?
Is this slope 0?
Yeah, right. If I'm coming from this side, what's the slope at P? They tell you the equation is y equals 2x there. So what's the slope there?
2.
Right. So that one has a slope of 0. That one has a slope of 2. So that's y. That's all you have to do for those.
So, this one, 2. This one's a curve.
Questions?
On number 3, why would the curved one be 0? Like the y equals square root x.
If you're coming from this way, as you approach P, it's going to become closer and closer to a horizontal line. Do you see that? Yes? Like if I have a curve like this, and I'm asking for the slope of the tangent at that point, it's going to be 0. Because it's going to be a horizontal line.
Then on number 4, why is the coming from the right approaching, why is it negative infinity?
Because, so we're going, whoa, oh, it's erasing, no wonder. We're going like this, like, okay, here's your curve. The tangent at that point is going to continue to get steeper and steeper until it's almost a vertical line, but it's not quite, it's slanted just slightly to the left, which makes it negative, and it's gonna become a really big number as it slants more and more and more.
Okay.
Does that make sense?
So on the curves, do we always find the tangent and see where the tangent is?
Right, because this is saying compare the right hand and left hand derivatives. The derivative is the slope of the tangent line at that point. Okay. You are most likely not going to see this again. It's just to show you that if you ever did come up with a function that looked like that and they were asking you to find the derivative, you'd be like, no, I can't. Like, so you would know that you couldn't do it, so that you wouldn't try to find something that didn't exist. But they're not going to ask you for that very often because they want you to be able to find the derivative of something. So I didn't want to spend a lot of time on it, but I do want you to understand why the derivative doesn't exist at that point.
Right.
Do you?
It doesn't, okay. Does the derivative not exist because the slopes are different?
Right. Coming from different directions.
Oh,
And
Okay.
derivative is the slope of the tangent, and differentiate.
That means, that's like saying find the slope of the tangent.
Okay.
Differentiate means to find the derivative.
Okay.
Alright, and then on the second half, mine has the answers on it, but, we did 5 together, right?
yeah.
Okay, so 6 is similar to 5 because there's no point where it's not differentiable. All of those derivatives would exist. So let's look at 8. 8 was the really strange one. So where is it not differentiable? At what x values? Crossing out the answers, you can't see. Can you tell?
I think.
There's 3 places, 3 x values in the domain that you could not find the derivative for.
Maybe 2, 0, and 3.
0 and 0 is 1 because there's a hole here. The other 2, no. Because it's not,
And would it be?
because 0 is not continuous. If it's not continuous at a point, then you can't find the derivative of it.
So 2.
2 is 1. So where x equals 0 and where x equals 2. And there's one other spot where you couldn't find the derivative of it.
Is -1 a corner?
Right, negative 1. Okay, so it's, for A, it says where is it differentiable, so it's differentiable, all points. All points in the interval, which would be, from -2 to 3, except where x equals -1, 0, or 2. That's where it's differentiable. And then it says, where is it continuous but not differentiable? So the function itself is continuous, but we can't find the derivative of it. So of those three x values, is there any place where it was continuous but not differentiable? Where is the function continuous? Of these 3 points, one of them is continuous. The function is continuous.
-1.
Yeah. We don't have to pick up our pencil to draw it at, right? So it's continuous, but we still can't find the derivative there because it's a corner. And then part C says, where is it neither continuous nor differentiable? So where is it not continuous? 2 and 0. Is it making any more sense? Kind of. So if you look at 7, where is it, basically, where is it not continuous? Or where is it not differentiable, I should say?
0.
0, right. So there's a point. There's a point there. But there's holes there and there. So it's not continuous at 0. So that's the only point where we can't find the derivative. So for A, you would say, well, it's up here, the answer is all points in -3, 3 except where x equals 0. And then, I don't know if you can read that. Okay. And then for B, where is it continuous but not differentiable? Well, we only have one point where it's not differentiable, and that's 0, and it's not continuous there, so that's none. And so therefore it's neither continuous nor differentiable at x equals 0. Skylar, are you with us?
Yeah.
Yes? You get it?
I think so.
So just to review what we talked about yesterday in your notes, there's 4 cases where the derivatives do not exist, or where you cannot find the derivative. Where there's a corner, like this, like an absolute value function or any place it's pointy. Where there's a cusp, which is like the extreme case of the corner, where it's curved and then it goes in a different direction. We didn't have any examples of this, I don't think, on those, but where there's a vertical tangent, like at 0 here, the tangent would be a vertical line. And where there's a discontinuity. So anytime you have a function that's discontinuous, it will not have a derivative at that point. And that's basically all I wanted you to get out of that section. Is if you see anything like that, I want you to recognize that you won't be able to find the derivative of it. Okay? So now we get into the fun part. Rules for derivatives. So all of the longhand stuff that we've done so far using the definition can be boiled down into rules that we can apply that we will use in every case that matches the situation. So the first one is the derivative of a constant function. So if f is the function with the constant value c, what's a constant? You guys know what a constant is?
I know we do. We've seen it before, but
It's just a plain number. So if that's like if we're finding the derivative of 4 or -8 or 2, c is a constant, that means it doesn't have any variables. Then that's saying df of dx equals d dx, or the derivative in respect to x, of c equals 0. So all of that, I want to write all of these in other words so that we can translate them to English. In other words is saying, any idea what it's saying in English? No? Okay. That means that the derivative of a constant, or in other words, a plain number, is always equal to 0. So anytime you're asked to find the derivative of a constant, like 5, 7 in this case, it says differentiate the function y equals 8. So we're finding the derivative of y, the function y equals 8. When we say derivative, we use, if they give you y, we say dy dx. Or you could say y prime equals what? What's the derivative of a constant always going to equal? 0. And you could prove that using the definition of the derivative, if you wanted to. Okay. The second rule is the power rule for positive integer powers of x. And it says that if n is a positive integer, then the derivative of x to the n power equals n times x to the n minus 1 power. In other words, we move the exponent in front of the x, or let's say in front of the variable, and then subtract 1 from the exponent. So if you have x to the nth power, we move whatever the power is. In this case, it says n to the front to be the coefficient, and then we subtract the exponent I1. So for example, differentiate the function f of x equals x to the 6th. So when we're given f of x, I usually write the derivative as f prime of x equals what do you think?
Six
6
minus 1.
x to the
Six minus one.
which is
5.
Yep. Okay. So you take whatever the exponent is, move it to the front as the coefficient, and then you reduce the exponent by 1. Every time you have a power like that. Okay? Alright, the constant multiple rule. If u is a differentiable function of x and c is a constant, then the derivative of cu, the constant times the function, equals c times the derivative of u, du dx. In other words, you, if function, let's say, when a function is multiplied by a number, find the derivative of the function and then multiply it by the number. Does that make sense? So for example, differentiate the function y equals 2x to the third. So that would be 2 times whatever the derivative of x to the third is. So what is the derivative of x to the third power? Using the last rule, the power rule.
3x raised to 2.
Yep. That's exactly right. So the derivative of this would be 6x squared. Okay, and the last rule that we're going to do today is the sum and difference rule. Which says if u and v are differentiable functions of x, then their sums and difference are differentiable at every point where u and v are differentiable, and at such points the derivative of u plus or minus v equals the derivative of u plus or minus the derivative of v. In other words, we can find the derivative or the derivatives of each term and add or subtract them to get the derivative of the whole function. So for example, differentiate the function f of x equals x cubed minus 2x squared. That means that we can find the derivative of x cubed and then subtract it with the derivative of 2x squared. So what's the derivative of x cubed?
Squared.
3x squared minus, and the derivative of 2x squared would be 2 times the derivative of x squared, which would be 2x. So in other words, this would be 3x squared minus 4x. What do you guys think?
makes sense. I think I just have to memorize the rule.
We'll practice. What do you think?
I don't know.
Alright, well, I do have